video 2 of our similar chapter here. We're going to focus now on some shortcuts. Just like in last chapter, or not last chapter, the congruent triangle chapter, we had 5 shortcuts. We had side, 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 angle, side, angle, side, angle, angle, side, and HL. And we will have shortcuts for similarity stuff. There's only going to be 3, which is nice. There's fewer shortcuts. 2 of them are really the same exact letter combinations as we had before for congruent stuff, but there's one that we couldn't use before, but that we can now use. So really, out of our 3 shortcuts, there's really only one new one. Now, in the previous video, we talked about how do you know that polygons or triangles are similar? Well, if we focused on triangles, we would need to know that all 3 sets of angles match up exactly, and that all 3 sets of sides were proportional. And so we could have 6 total things we would have to examine here. But just like before with congruent stuff, we didn't need to know all of the sets were the same to say that they were congruent. So we do not need to know all 6 pieces for triangles, 3 sets of angles, 3 sets of sides. We can get away with even 2 pieces of information and 3 pieces just like we did before. So let's talk shortcuts. Now, we can safely say 2 triangles are similar only knowing 2 sets of angles are congruent. Really? Yeah, really, bro. Let's take a look at this. So I've got Sketchpad here I'm popping up. Let me show you some stuff coming up here. So let's say I have this triangle and angle A is 70 and angle B is 30 degrees. So just knowing those 2 angles, a 70 and a 30, we know what angle C, the third angle, would have to be, right? It would have to end up being 80 degrees. And how do we know that? Well, triangles only have 180 degrees. So once we knew 2 angles, we technically would know the third angle. We would just subtract the first 2 from 180, and we would get it. So if we know 2 angles, can the third angle value change at all? No, it can't. It's fixed. Now, here are the 3 side lengths of triangle ABC. And here are the proportion of sides. Now, typically you're not just focusing on one triangle, you're focusing on multiple triangles, but I can show you that the proportions aren't going to change even though I change the appearance of this triangle, okay? So watch as I resize this triangle here. You'll notice that the angle values, they're not changing at all. But you'll definitely notice the side lengths, they are changing. Okay, this thing's just jumping all around. But notice the proportion of the sides don't change. And they would change if it was possible, but they're not. So I'm saying this triangle is similar to this triangle, is similar to this triangle, is similar to this triangle, similar to that 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 triangle. There are really infinitely many triangles that I can have here that are all similar to each other because all of the angles are staying the same and all of the sides are staying proportional to each other. Okay? So just having 2 matching angles, just having a 70 and a 30, make those 70 and 30, which means the third angles must be the same, and notice all the sides were staying proportional with each other. So that's taking us to our first shortcut, angle, angle. Just knowing 2 sets of angles and 2 triangles makes those 2 triangles similar to each other. Okay, so this is really like the best shortcut in the world because it's only 2 things, right? Everything else we needed 3 things. Now there's one little thing you'll have to add here. Angle, angle, we'll always say angle, angle, similarity. And we need to include the similarity symbol here, the little tilde. So if you ever wanted to say that 2 triangles were similar by angle, angle, we're going to write angle, angle, and then the squiggle right after it. Okay, so these 2 triangles are similar because of angle, angle, similarity. And you'll ask, why do we have to put the squiggle there? You'll see when we do the next 2 shortcuts why we need to put it there. So, first example, are these 2 triangles congruent? I don't know. Let's see. I've got 1 set of matching angles. I can see I've got some matching 90s, but I got a 61 and a 29, and those aren't the same, so I don't have angle, angle, right? Well, maybe, maybe not. We don't know what the third angles are in both of those triangles. So let's quickly figure out what those may be. So 180 minus 90 minus 61, I'm really subtracting away, what, 151 degrees? Which leaves me with 29 degrees, which is F. OMG. I got matching 29s here, which means I have angle-angle. So are the triangles similar? Answer, yes. Why? Angle-angle similarity, which really means how big would K end up being? Well, K would end up being the same thing as H. It would have to be 61 degrees. Okay? So write a similarity statement. Triangle, let's say I call this one alphabetically, FGH, is similar to triangle. Can I go alphabetical here? I don't think so, right? Oh, no, wait. Since I start with the 29 was F, I got to start with J. And then I went to G, which was the 90, and L is the 90. And then 61, which was H, was the last one, and K was the other 61. So it's not necessarily in alphabetical order here. F, G, H, and J, L, K aren't alphabetically inclined there. So there's our similarity statement. Now, if you can only show that one set of angles match, then those triangles aren't similar by angle-angle. So you have to have the two sets of matching angles to say angle-angle. By default, the third angles will match up. Who cares what they are? Second example, is there enough information to show these triangles are similar? If so, again, write a similarity statement. So the first thing we immediately notice is, yes, we have matching 105s. We've got 1A down. We need 1A to go. But we don't really have any other numbers here. So what to do? Well, you might notice both of these triangles, RSV and RTU, they really share an angle, right? They both use angle R. So wouldn't angle R in one triangle be congruent to the same angle R in the second triangle? And yeah, that would be true. We could mark angle R as congruent to itself. Now, why? Think about if we were doing a proof, which we're not, why could we say that angle R is congruent to angle R? Well, that would be the reflexive property. We've never really used the reflexive property with angles. We've always used it with sides. So here's where you might run into the reflexive property with angles. Okay, so now we do have our second A. So yes, these triangles are congruent by angle-angle, and the similarity statement would be, let's say I went RSV, and the other one would have to go RTU. Now, a second point I want to point out, no pun intended, is something maybe some of you saw whenever we only talked about the 105s. If I were to extend out SV and TU as two lines, and if I were to emphasize RT as a transversal, what type of angles are the 105s? And you might say, oh, they're corresponding angles. They are, and they're congruent, which means only one thing. SV is parallel to TU. Now, since that's true, guess what's going to happen over here when I talk about this transversal? Well, that must mean that this angle, RVS, is congruent to this angle, RUT, because they are corresponding angles. And we know we have parallel lines at this point. So again, we could have had angle-angle similarity without even mentioning the reflexive angle. So keep in mind and be on the lookout for potential parallel lines. And if you can show they're parallel, you can pick up some additional angles out of that. Example 3. Is there enough information to show we have congruent, or not congruent, similar triangles? If so, similarity statement once again. Well, okay, so the first thing you should hopefully immediately notice is we have matching 87s. So again, we've got 1A down, we got 1A to go. Some of you are immediately going to see, hey, we've got vertical angles, and those are always congruent, so we do, again, have similar triangles. And so we could write, let's make this one interesting, triangle HAM would be similar to triangle, well, let's see, H didn't have any marking on it, and N didn't have any marking on it, so they would match. A matches with A vertically, which by process of elimination, B would be our last one. We have a ham nab, or we should nab the ham. Which one? I don't know. Now, is there anything else mysterious about this one like there was with 2? How there was 2 ways of seeing it? And there is. Again, notice if we were focusing on, let's say, these 2 lines, BN and HM, with this as a transversal. What kind of angles are the 87s? Oh, well, they're alternate interior angles, and they're congruent. Therefore, these two sides are really parallel to each other. HM is parallel to BN, which means, if we refocused our attention on a different transversal, oh, well, that means this angle, N, is congruent to this angle, H, because they are alternate interior, now with known parallel sides. So we could have completely ignored the vertical angles and still reached our angle-angle similarity conclusion. Second shortcut, side angle side, squiggle mark. This is why we have to put the squiggle mark here. Because if I didn't put the squiggle mark and you saw side angle side, you would think these two triangles are congruent. But that's not necessarily the case. So if you see side angle side squiggle mark, that means that they are just similar. If you say side angle side no squiggle mark, that means they are congruent, meaning that all the sides are congruent and not proportional necessarily. So what you need to see for side angle side is, hey, what do you know? Side angle side. Now the angles, the A's, must match up, which in this case, look, 90, 90 they do. For the sides, though, we have to check if they're proportional. Now, with side angle side, notice there's only two S's, which means there's only two ratios we've got to check. So this is how a quick check would look like here. Here's our two S's, and I'm just going to do small and large, small and large. I'll say this represents the left triangle. Let's say this represents the right triangle. Left triangle, small, large, would be 3 and 6. Right triangle, small, large, would be 4 and 8. So what I need to check is, are these two really congruent to each other? Well, 3/4 is as fully simplified as it gets, and 6/8 has a factor of 2, and it would simplify to be 3/4. So we do, in fact, have proportional sides in here, or at least our two sets of sides. Now, because we have this side angle side, means all together the whole triangles are similar to each other, which means these angles must match up and be congruent. The third set of angles must match up and be congruent. And really, we could use the Pythagorean theorem with both of these. Let's see, 36 and 9, 45. This would be the square root of 45, which simplifies, of course, to be 3√5. And 4 and 8 here, let's see, 64 and 16 is 80. So the square root of 80, square root of 80, that would be 4√5. And so we could set a ratio with that, 3√5 to 4√5. What do you know? The root 5's cancel. Boom, there's our 3 to 4 ratio that we saw with the other two sets of sides. Whew. You guys pumped because I'm sweating. This is getting intense here. Whew, I need a little breather. Time out. All right, let's go. Third shortcut, side, side, side. All you need to know, if all three sets of sides are not congruent but proportional, then overall the triangles are similar, which means by default all three angles would have to match up. Now to prove that triangles are similar by side, 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 you just have to check all three sets of side ratios. And again, let's just set it up like this. Left triangle, right triangle, small, medium, large, small, medium, large. Now, in the left triangle, small and medium, we got a tie here. So which 6 do I know where to put where? Doesn't matter. Over here, we got 8, 8, and 12. 8, 8, 12. So we're checking now. We got to verify that all three of these are really the same. Now, in this specific example, we obviously know the first two are going to match because they're the same numbers. So 6, 8, 6 eighths, we know we're going to get 3/4 out of when we divide each by 2. Now, 9 twelfths have a common factor of 3, which we also get 3/4. So that's what we want to see. We really want to see the same ratio matching 3 times over. So these two triangles are similar by side, 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 which kind of like my CPCTC information, but it's now more CPSTC. Corresponding parts of similar triangles are not necessarily congruent though, because the sides aren't congruent, they're proportional. We'd have to have kind of like two different CP type statements, one for angles and one for sides, because one angles we need congruent and sides we need proportional. This is intense, guys. This is intense. Okay, so we really can't have CPCTC stuff. Okay, but anyway, these angles would have to match up, and these angles would have to match up, and because those are isosceles, those are my brain is just working way more than my mouth can keep up with at this point. But we know these angles would have to match. And I could go ahead and put a third side there and put 2 there with 2 there. There, we'd have something like that. These would kind of be my CPCTC-like information. All right, example 4. Are these triangles similar? If so, why? When I first look at these two triangles, I notice that they gave me all 3 sets of side information here. Chances are I'm not going to use any type of angle, right? They didn't give me any angles here. They didn't give me any angles here. So out of my 3 shortcuts, I'm probably not going to be using these 2 because they didn't, again, give me any angle information. So I'm going to hope that it's side, side, side. Does it mean it's side, side, side just because they gave me 3 sets of sides and 3 sets of sides? No. You have to check, are all 3 sets of sides proportional to each other? So let's take, that's an awful S, small triangle to big triangle, set up 3 ratios, and let's do small, medium, large, match it up with small, medium, large. So small triangle, small, 22, medium, 30, large, 40. Do the same thing with the big triangle, small, 32, medium, 45, large, 60. So here's what we're testing. If it's true that all 3 of these ratios are equal to each other, we've got side, 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 aka we have similar triangles. If these are not congruent to each other, we don't have proportional sides, which means we don't get to use side, side, side similarity, which means these 2 triangles are not similar to each other. So let's check. 22 and 32 have a common factor of 2, and we have 11/16. 30 and 45 have a common factor of 15, and we get 2/3. We may immediately stop at this point and say, sides, since the sides are not proportional, the triangles are not similar! Exclamation point, not factorial. And that would be our answer here. They're not similar because the sides are not proportional. So it's this type of stuff that I will be looking for on quiz and test type questions that I'll ask. Okay, I'm not just looking for this as your final answer. You know, what does this mean that you get 2 not equal ratios? Well, it means this over here. This is the meat and potatoes of your answer. This is supporting evidence of your meat and potatoes.